Hi everyone, welcome to my YouTube channel. Here I bring you a presentation. As you can see clearly, it is the prediction of the students' performance in exams using the AI system. My name is Sarah, and as I take you through this presentation, first of all, I bring you the introductory part of it, that is the the project that I'm going to be doing. It is a school project that I will be using AI and machine learning. As you can see clearly that this is the AI and machine learning project for predicting the student's performance in an exam. First of all, we begin by defining what is AI. AI means artificial intelligence, and which is the ability of the machine to display human-like capabilities such as reasoning, learning, planning, and creativity. Machine learning, on the other hand, refers to the study of computer algorithms that improve automatically through experience and by the use of data, and is also called the subset of AI. As you go down in the next slide, there are always, whatever you do something, there is always an objective. You need to achieve a goal. The objective of this project is to obtain a quantitative prediction model to predict learning performance of students in online learning, which can be used to analyze the contributions of input variables to academic performance and therefore optimizes the design of online courses based on results. As we go in the next slide, predicting students' performance as a problem, I need to solve it and come up with the best results. Predicting students' performance is not an easy way, as we know. There are always procedures and things that we follow to make sure that we see the best results. And that is always done by giving students an assessment, and after assessing them, the lecturer or the teacher has to mark so that you can come out with the results depending on the scores of the individual student. So I came up with this idea because I need to implement a system that can predict the students' results basing majorly on the previous algorithms or patterns that students did exams. So it's always a very big challenge, but as I told you, I'll be implementing an AI system to help us come up with a solution. The next slide here is that the data set to be used. Maybe before I go on the data set, I was still explaining about the objectives. The objective of this project is to obtain a quantitative predictive model to predict learning performance of students in line. I think as I bring you here, bringing this quantitative prediction model is not easy, but as you see, it will come to pass when I implement that. When we talk about that, predicting the students' performance, it's not an easy thing to do, but you'll have to look for the data set that you can use basically to make things work. And here, I can define what a data set means. A data set refers to the collection of data that may be in tabular form corresponding to one or more database tables, and every column of the table represent a particular variable. First of all, here I'll be using the type of data set is the student's performance in exams. That is the data set I will be using. Other data set for my project. This data set consists of students' names, gender, score, and class group, depending on how classes are grouped. Maybe in group A, B, as in primary, you can be in B or C, depending on the class that you belong. Going to the next slide, the factor that I considered for using this data set is one of them is the performance. Actually, everything when you're considering doing it, you have to consider some factors so that you're free and able to do everything. So performance here, this data set gives high quality results since the results will be displayed clearly for the specific student. As you can see here, it is really self-explanatory. Another factor I considered is the research goal. Since this research that I'm doing, that I want to implement, like to determine the performance of students, I selected data set because I am doing on performance of students. I want to predict how students perform, how they get their goal, like their scores in respective course units or subjects. The next one is inference time. This is the amount of time it takes to run and make predictions. Thus, it is fast enough. So I had to consider such a factor. That's why I selected it. Another one is the data set size. This is the amount of training data available in my data set, which gives clear content easy to understand. As you clearly see, once you're given a data set of students, it will contain the sex, what I mean, the gender of a student, that is maybe a female or a male. So it is really so easy to understand. That's why I chose students' performance in exams. When you go to the next slide here, the features that my data set constitutes, like the contents of it. One of them is the gender. I just clearly explained in the previous slide is that the gender, it contains the gender of a person, whether you're male or female, it's a self-explanatory. Another one is the score, the mark that a student obtains in a specific exams, he or she sits for it. So my data set will always have that column for the score. And then another one is the group. This group, you will be able to see it in my data set, where you belong, whether you belong in C, you belong in B, or you belong in science, evening or day. Another one is the course, the subject or the course unit, what you're doing, because you cannot just come and do anything. So the data set will always constitute the subject name or the course unit name. Another one is the parents' level of education. We really need to determine that one as well. As you go to the next slide, there is a Bayesian theorem here. This is like, these are theories we grew, we found them there, so we are told to define them. As you can see clearly, see here, the Bayesian theorem states that the conditional probability of an event based on the occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the event. As you can see here, it's actually named after the English statistician. Of course, for us here in computer science, we study probability and statistics. So this was one of the great guys, the great man who discovered this formula in 1763. And this is the formula. We read this as the probability. P means probability. Probability of A given B, assuming you're given two events, A and B. So the probability of A given B is equal to the probability of B given A and the probability of A divided by probability of B. I know you may not have the base content about it, but I'll refer you to my previous references down there. You'll be able to derive that, and especially if you're a mathematician, I know I'm talking to the right person. When you go to the next slide, there is also the naive bias. The naive bias classifier is an algorithm that uses bias theorem to classify objects. It assumes a strong or a naive independence between attributes of data points. Popular uses of it include spam filters, text and analysis, and medical diagnosis, and it's widely used for machine learning because they are easy to implement. And I already explained more about machine learning, AI in my introduction. So the next one, as you see, the Bayesian network. The Bayesian networks refers to the probabilistic graphical models that represent a set of variables and their conditional dependencies via a directed cyclic graph. So all these are mathematical terms, but for more understanding, I refer you to my references. There are relevant references in the down slides. You'll be able to refer yourself there, find time and explore the Google and the internet. And next one, I have here the differences between those two words. As we clearly saw in the previous slide, the naive bias assumes conditional independence, the relationship between all input features are not independent. You get? Then here, Bayesian theory does not assume conditional independence, meaning the relationship between all input features are independent. It is self-explanatory. You just have to put your eye and see how things are done. When you go to the next slide, I also bring a difference between naive Bayes networks and Bayesian network. The difference of this, like in naive Bayes network, a naive Bayes network refers to the probabilistic classifier based on the application of Bayes theorem. The Bayes theorem, I already stated it above. And here, when you come to the Bayesian network, the Bayesian network refers to the probabilistic graphical model that uses Bayesian inference to the probability computation. The inference like means the time, the interval it takes to bring in an output. When you go to the next slide here, I bring you references. I know I have been talking about these things, there are more, and it is not easy to understand them, especially when they come to your ear for the first time. But here is a list of references. You can have a tap on it and you'll be able to go to the right direction and get more understanding here. In conclusion, as I conclude, an idea to predict students' performance helps a lot in determining the performance so fast based on the previous pattern using AI system. That's simplicity and saves time. Predicting, you really don't need to wait like for this, for the marks to be marked, the teachers have to do everything, implementing, no. You just have to implement an AI system that will just predict depending on the previous algorithms. So it is really a very good project for AI and machine learning. And I am sure you'll enjoy it. I will be keeping you updated. I will be uploading a lot of videos concerning how I will be doing the coding and everything. You will like it, trust me. As I finally go, I really want to appreciate everyone who is watching me right now, and all the subscribers of my YouTube channel that will continue viewing, continue being updated. Appreciate it for your time and everything that you've done. Thank you.